Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss nomenclature of organic compounds having functional groups. Last class I have discussed nomenclature of branched alkane, branch chain alkane. Now I am going to discuss nomenclature of organic compounds having functional groups. A functional groups, first we should know what is the functional group. Already I have given example, but now it is the right place to tell about functional group. A functional group is defined as a atom or a group of atoms bonded together in a unique manner, which is usually the site of chemical reactivity in an organic molecule. Compounds having the same functional group undergo similar reaction. For example, methyl alcohol, ethyl alcohol, CH3 CHOH, all having OH functional group liberate hydrogen on reaction with sodium metal. The presence of functional groups enables systematization of organic compounds into different classes. Examples of some functional groups with their prefixes and suffixes, along with some examples of organic compounds. I will give you complete. I will tell you, just to listen carefully, that organic class of organic compounds, functional group structure, IUPAC group prefixes, IUPAC group suffix. Example I will give you, then you will understand some functional group and classes of organic compounds. Then first to understand the groups, and then you will understand the nomenclature. Now alkane, already told you that alkane, that is a methyl group, alkyl group, propyl group, that is the alkanes. Okay, and the end IUPAC group suffix, that is the ANE, example butane. Butane means here CH3 CH2 CH3, total 4 carbon. Now alkene, carbon double bond, between carbon double bond, and its suffixes IUPAC group suffix ENE, in. Example butane, BUT, shortcut BUT1 in, like that way. Alkyne, carbon triple bond, and suffixes IUPAC group suffix YNE, alkyne, that YNE, alkene ENE, last was ENE, and alkane ANE, then YNE, that is the suffix. An example is butane 1 YNE. Butane means BUT, shortcut but-1 YNE. This is the example of this alkynes. Now arenes, arene, arenes, arenes. Here you know alternate is benzene I am talking about. Example is benzene. Here no prefix, no suffix. Benzene. Okay. Then benzene is already told you that is also called arene. arene, arene. Then here just it is a 6-membered ring. 6 carbon rings are there. 6-membered ring and alternate double and single bond, but one circle will be there. Inside one circle will be there. That means electrons are moving. Double bond will become single bond will become double bond. Rotation. That's why it is a ring will be there inside the 6 carbon ring. One circle will be there. This I told about the arenes. Halide means X, capital X. X may be fluorine, chlorine, bromine, iodine, and its prefix is halo, 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 and example that is a 1-bromobutane, 1-bromobutane. Here bromo, that is the prefix. Now alcohol, OH group. Alcohol is OH group, and also IUPAC group prefix. Its name is hydroxy. This is the IUPAC group prefix, hydroxy, and IUPAC group suffix is OL, means in compound and the end you will write OL. Example butane -2-all. Butanol in general we are telling butanol, but according to IUPAC it will be butane -2-all. Aldehyde, already told you, CHO is a group, a functional group, and what is its IUPAC group prefix? Then it is a formyl or oxo. Don't forget, aldehyde prefix is a oxo or formyl, and suffix is al, means aldehyde, short form al, that is a aldehyde, 2 letter. Then its example is butanal, butanal. In butane, just you remove the last ANE and you add al, butanal. Al means aldehyde. Ketone is CO, carbonyl group, that is also called carbonyl group, CO, and its prefix is oxo, oxo, and suffix is one, ketone, then one, one is the suffix. Suffix always will be written at the end. All suffix will be written at the end and prefix will be in the beginning. Then ketone suffix is on and prefix is oxo. An example is butane to on, butane -2-on. By seeing the structure, you can automatically spell like that, butane -2-on. Now ketone already told you. Now nitrile is CNN, triple bond N, cyanide, and its prefix is cyano, 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 and this suffix is nitrile, nitrile, nitrile. Example, that is a pentane nitrile, Penta, pentane, and just write nitrile, pentane nitrile. Example. Now ether already told you. Now it is the right place to tell all the things. Ether is ROR. In the middle O is there, right side R, left side R. ROR. Both R has 1 valency, so that it can join with others. And prefix is alkoxy, ALKOXY, alkoxy. Example is no suffix. Example is ethoxy, ethane, alkoxy. I am telling you, ALKOXY, alkoxy. That is the prefix. Then example is ethane, ethoxy ethane, you can tell, ethoxy ethane. Now carboxylic acid. Carboxylic acid's group is COOH. COOH, C has 1 valency. Just to join, 1 dash, COOH. And it is here it is also called carboxy group. IUPAC group prefix is carboxy, and suffix is, in the end you will write OIC, oic acid, oic acid. Example, butanoic acid. Now carboxylate ion. Carboxylic acid is there, COOH. If from that H will go, then what is left out? Means COO, 1 minus will be left out. Then that is called carboxylate ion, COO, 1 minus. And what is its suffix? No prefix. Suffix OATE. Okay. Example is sodium butanoate, BUTAN, butane, and OATE, just to add it, OATE, then sodium butanoate. Now ester group, already told you, ester is RCOO. Now suppose 1 R is not there, then 1 dash will be there, COOR. 1 valence is the open valence, that is that for joining, and that is a group, COOR, that is the ester group, and its prefix is alkoxycarbonyl, because COO group is there, COO, that's why it is known as alkoxycarbonyl. Alkoxycarbonyl is prefix, and what is the suffix? OATE, same way what was with carboxylate, same way here OATE, here also OATE, and its example is methyl propanoate, ethyl propanoate, like this way. Now acyl halide, ACYL, acyl halide, that is the COX group. Okay, group means always 1 valency will be there, opened to join with anything others. Then COX, where X is equal to FCl, Bri, means fluorine, chlorine, bromine, iodine. Okay, And what is its prefix? Then halocarbonyl. See, continuous three names are like that way. Two names. Alkoxycarbonyl, that is for ester, and for this halocarbonyl. And what is suffix? Suffix is OYL. OYL, while halide. While halide. Example, butanoyl chloride. Butanoyl chloride, butanoyl bromide, like that way. And amine group is NH2. NH2 is called amine group. N also you can tell NH or N. NH2 is there. Suppose now one H is attached, then two bond will be opened. NH group. If suppose only one is there, then that will be N only. N. Okay, three bond it can attach. And this is called amino group. Amino prefixes amino and suffixes amine. Both senses same. Amino group, that is the prefix, and suffix is amine. And what is example? Butane dash 2 dash amine. Butane dash 2 dash amine. Now what is the amide group? Amine is NH2 or NH or N, you can tell. Now amide is CONH2. NH2 is there but with CO. Then CONH2 group, that is called amide group. And its prefix is carbamoyl. 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 And suffix is amide. Example is butanamide, or you can tell butanamide. And nitro group, nitro compounds, that is the NO2. Then this is the group and prefix is nitro, no suffix. 1-nitrobutane is example. 1-nitrobutane. 1-nitrobutane is the example. And sulfonic acid, that is the SO3H. And its prefix is sulfo. SULPHO, sulfo. And what is the suffix? Suffix is sulfonic acid. SO3H is called sulfonic acid. Then nitro, I told you nitro compound is NO2. Prefix is nitro, no suffix. 1-nitrobutane. 1-nitrobutane is example. And sulfonic acid is SO3H. One valence is there to join. Every group will have open valency one just for joining, just to join. Then SO3H means sulfo group, or you can tell IUPAC is sulfo prefix. Okay, group prefix. And suffix is sulfonic acid. Example is methyl sulfonic acid. Then this I have discussed in details all groups. Now further I am telling you. Functional groups, the presence of functional groups enables systematization of organic compounds into different classes. Now, first of all, the functional groups present in the molecule is identified, which determines the choice of appropriate suffix. Now I am coming towards nomenclature. How will you do nomenclature? Having functional group, compounds having functional group. How will you do this nomenclature? Now I am telling you. The longest chain of carbon atoms containing the functional group is numbered in such a way that the functional group is attached at the carbon atom possessing lowest possible number in the chain. Again you listen, the very longest chain first you have to find out, and in that chain group will be attached. Any particular group will be attached. Then where will attach this group, to which carbon it will be attached? Then now you listen. The longest chain of carbon atoms containing the functional group is numbered in such a way that the functional group is attached at the carbon atom possessing lowest possible number in the chain. Okay, now one example I am giving you. As for example, CH3, this CH2, CH2, CH3. Suppose this compound is there, then CH2CH, double bond is there. Between CH2 means butane 1 in, then here double bond is attached with carbon first and second, then butane 1 in group is very group got number, carbon number is list. Okay, group got list carbon number. And next example I am telling you, that is the butane 1 YNE, butane 1 wine. Butane 1 wine means triple bond. Then now again you can see butane 1 means carbon got or group YNE group is attached with carbon 1, just like double bond ENE was attached with first carbon, got first carbon. Like that way YNE also got first carbon, numbering got 1. Correct? Now another example, 1 bromobutane, then bromo is attached with first carbon, means numbering will start with first carbon. Then like that way, and group is attached in such a way that it should get a possible lowest number. This is a very, very important thing. In the case of polyfunctional compounds, polyfunctional may be more than 2. More than 2 means poly. In the case of polyfunctional compounds, one of the functional group is chosen as the principal function group, and the compound is then named on that basis. Again, important things, all are important only. That next important point is that if more than one group is attached, then one group will be parent. And other group accordingly you have to attach. Then in the case of polyfunctional compounds, one of the functional group is chosen as the principal functional group or parent or principal functional group, and the compound is then named on that basis. The remaining functional group, which are subordinate functional group, are named as substituents using the appropriate prefixes. The choice of principal functional group is made on the basis of order of preference. I am telling now very just I will tell you name of the groups. Which group will come first, to which you have to give priority. Means a principal group. Which will be the principal group? Many groups are there. Many groups are there, or in that compound maybe 2-3 groups are attached. Then who will get the first priority? Who will get the second priority? Who will get the third priority? That I am going to tell you, and this is very, very important, and in examination it will help you too much. Hence, listen carefully. If you have pen, pencil with you, paper, you can note down also. The order of decreasing priority for some functional group is, now I am telling you, top priority is for COOH, carboxylic group, COOH, that is the top priority. After that, second priority, decreasing order, now I am telling you, second priority is SO3H. Third priority is the SO3H, that is the sulfonic group, and third priority is for ester, third, and fourth priority is for acyl group, COCl, fourth. Fifth is amide group, CONH2. Sixth is CN group. 7 is HCO group, means aldehyde group, CHO group or HCO group, aldehyde. Next preference is carbonyl group, CO, and after that OH group, hydroxyl group, alcoholic, OH group, and after that amino group, NH2, and after that ene group, ENE, double bond, carbon double bond, ene group, and last weightage is for triple bond, carbon triple bond. Okay, again I am telling you, COOH group is the top, first priority. Second is the SO3H. Third is COOR. Fourth is COCl. Fifth is CONH2. Sixth is CN. 7 is CHO, means aldehyde. 8 is CO. 9 is OH. 10 is NH2. 11 is ENE, double bond, carbon double bond, and 12 is carbon triple bond. This always you remember or keep in mind while doing the IUPAC nomenclature. The R group, the R6 means alkyl group, benzyl group, halogens means fluorine, chlorine, bromine, iodine, nitro, alkoxy, OR, etc. are always prefix substituents. Again, next important point, alkyl group minus R, you can not means R, one this R group, one valence is there to attach. R group will be like that, one valence will be opened. Then alkyl group, benzyl means C6H5 group, halogens means F minus, Cl minus, Br minus, I minus, or NO2 group, alkoxy means OR group, etc. are always prefix substituent. Thus, a compound containing both an alcohol or a keto group is named as. Now, this can understand here now. Now, suppose a compound containing both alcohol and keto group, both are there. Alcohol and keto group is named. How will you name if both are there? Then first priority will be for what? Hydroxy. I told you that hydroxy is there, alcohol and keto group is both are present. Then it will be named as hydroxy alkanone. Main will be ONE. Okay. I told you that first CO group is coming and then OH group is coming. What I told you, then OH group is coming. OH coming after first CO group and then OH group. Hence, CO will be given top priority as a primary functional group and OH will come after that. Then if both groups are there, then CO group will be the parent. Okay, parent or primary. Then if can say both an alcohol and keto group is named, will be named as hydroxy alkanone, since the keto group is preferred to the hydroxyl group. Okay. Then like that way, this what I discussed, that sequence you have to keep in mind. Now, other example I am telling you. This suppose when I am telling the one compound name, I am telling one compound I am telling that OH CS2, again CS2 whole 3 is there, again CS2 is there, again CO CS3 is there. This is the compound. Here you are saying OH and CO group both are there. OH with first carbon OH is there, and after that CS2 is there. After that CS2 3 is there. CS2 whole 3. Again CS2 is there. Again CO, then last CS3. Then how will you name this compound? Total carbon I am telling you 7 carbon atoms are there. 7 carbon atoms are there. Okay. Then here with first carbon OH group is attached. But how will you numbering 7? You can't tell. You can tell, no problem, because CO group, here 2 group is attached, OH and CO. Then CO is attached with carbon number 2. O group is attached with carbon number 2. Correct? And this OH group is attached at carbon number 7. Carbon number 7. Then how will you name this compound? Then here you can see CO and OH group both are attached. One is attached with carbon number 2 oxygen and carbon number 7 OH is there. Total carbon is 7 carbon atom, and all are single bond. Then how will you do nomenclature? Then very easy to do nomenclature. Carbon number this OH is and the end means carbon 7. Then you will do nomenclature as 7 hydroxy heptane. 7 dash hydroxyheptane. After that dash 2 again dash one, one. Okay, because this is the primary, then it will end with on, ketone, because finally it is a ketone. Then 7 hydroxyheptane, AN, heptane dash 2 dash on, and this like this way only you have to do nomenclature, because one primary first you have to find out which is a primary group. Now primary group is top priority is for ketone. Then obviously ketone is the primary, hence the main compound will be ketone only. That is in shortcut you will tell heptone, one, heptone, but correctly you have to write hydroxyheptane on, heptone you can tell, yes, but it is wrong. Correct way you write 7 dash hydroxy heptane dash 2 dash one. Okay, this I have told you. Now again further I am telling you, if more than one functional group of the same type are present, just like in branched alkane what I discussed, same way here. If more than one functional group of the same type are present, their number is indicated by adding di, tri, etc. before the class suffix. In such cases, the full name of the parent alkane is written before the class suffix. Okay, again I am telling you, in such cases, the full name of the parent alkane is written before the class suffix. For example, suppose CH2 whole 2, CH2 OH is in the bracket, CH2 again OH, 2 OH is there, both OH you are writing in a bracket, alcoholic group. Then CH2 OH again CH2 OH, means carbon is only 2, only 2 carbon is there, CH2, but for each carbon one OH group is attached. First carbon OH group is attached, with second carbon also OH group is attached, only 2 carbon is there, CH2OH again CH2OH. Then this is named as, first you have to write the parent alkane, first you write parent alkane, then 2 carbon is there, then ethane, 1 carbon is methane, 2 carbon is ethane, 3 carbon is propane, 4 is butane, 5 is pentane. Then like that way, first you write alkane, write the first name of the parent alkane, then it is the ethane, because only 2 carbon is there, ethane dash 1, 2 diol, because 2 alcohol is there, one is at carbon 1, other is at carbon 2, then ethane dash, same rule regulation what I discussed with the branched alkane, here also all things will be same. Then ethane dash 1, 2 dash diol. However, the ending means NE, alkane was there, ANE. Then NE of the parent alkane is dropped. Okay, there ANE, alkane has ANE. Then last word NE you have to not use. You have written ethane, then you have to write Ne you remove. Then what is remaining? Then it will become ETHA, eth. Ne you have to remove. Then eth, myth, like that way. Here Ne will be removed. First thing, any of the parent alkane is dropped. In the case of compounds having more than one double or triple bond. Okay, this Ne is dropped in the case of compounds having more than one double bond or triple bond. If more than one double bond or triple bond is there. Example I am telling you that in the when double bond and triple bond will be there, only that time you have to remove Ne only that time, not always, only that time. And then example I am telling you for this CH2 double bond CH, again CH, again double bond CH2 is there, means first carbon and third carbon double bond is there. Total 4 carbons are there, 4 carbons, and double bond is there. Then obviously it will be butene, ENE will be there. Okay, then double bond, 2 double bond is there, and butane is 4 carbons are there. Then it will be named as BUTA, buta, ANE was there, and the buta, last 2 letter NE you have removed. Buta, BUTA, ANE was there. Then A is there, buta is there, NE you have removed. Then its name will be buta dash 1, 3, buta dash 1, 3, diene, ENE, what diene. Okay, means what you have NE you have removed, here ENE you have to diene double bond, diene. Then this is the way how to do nomenclature. Then see if 2 double bond is there, carbon number 1 and carbon number 3, that's why 1, 3 you have written, 1, 3, a dash you have to write for the separation always. Then buta dash 1, 3, again dash diene. Okay, this I have told you. Now again further example is there. This question is asked actually in examination. That example I am giving now. Question is that write the IUPAC name of the compounds. 4 compounds, this compounds they have given from their given structure. A structure is there, you have to write the IUPAC name. Okay, IUPAC name you have to write of the compounds. 4 compounds they have given. Then you have to write the name of the all 4 compounds. Okay. Then first compound I am telling you. See carbon number, actually it is a octet. All are single bond, 8 carbons are there. Okay, now you know, if you are knowing the carbon and all are single bond, then you know that first and last will be the CH3 and other will be CH2, and if any other branch is attached, then one hydrogen is removed and other group you add. You know all the things, means carbon has 4 valency, tetravalency must be fulfilled. Then now I am first compound what is given I am telling you. Then 8 carbons are there, a structure they have given 8 carbons, first to 8, and carbon number 3 OH group is there, and carbon number 6 CH3 group is there, CH3 group. Then how will you do these things? Nomenclature. Then here carbon number 6 methyl group is there. When methyl and OH both are there, then top priority will be for OH. OH is closer to the end. It got OH got 3 number 3. Then obviously it is a primary group. Out of this, methyl is attached and alcohol is also attached. Then primary group will be OH group. It got list number 3. OH and CH3 got 6 number. Then its nomenclature will be 6-methyl, 6-methyl octane, because all are single bond. Then octane and dash 3 dash all. Alcohol, actually it is alcohol. OL you have to write. Then at which carbon? Then carbon number 3. Then compound will be 6-methyl, 6-methyl octane, octane, AN, octane, and after that carbon number you have to write. Then dash 3 dash OL, 6-methyl octane. Okay, methyl octane 3, methyl octane dash 3 dash OL. This is the nomenclature. And why you are knowing the OH is an carbon atom 3. The OH is on carbon atom 3. In addition, a methyl group is attached at 6 carbon. Hence, the systematic name of this compound is 6-methyl octane dash 3 dash OL. Always for the separation OL dash you write. For anything separation dash, and only for the same group comma you can write, or di and tri. Now second compound is, I am telling you, this is the, actually it has 6 carbon. It has 6 carbon, long chain, 6 carbon, and carbon number 2 and carbon number 4 both are same group, CO. OO group is attached. O is attached with carbon number 2 and other O is attached with carbon number 4. A total 6 is there. Then what will be the name? Then again you can understand both are O group. Then one group is at carbon 2. Then obviously this will be primary group. CO group will be primary with the CO is attached, and total is 6 carbon, and all are single bond. Only oxygen is double bond because it is a group ketone. Then its name will be systematic name will be hexane, because all are single bond. Hexane dash 2,4 dash dione, dione. Correct? Again I am telling you, hexane dash 2,4, because same are there. That's why same means comma you have to write. And carbon number 2 and 4 is there, 2, 4. Then hexane dash 2,4 dash dione, dione. One means ketone, one. Then this I have told you. Okay. Now third compound is again 6 carbon is attached. Total 6 is attached, and C double OH group is actually there attached. Two group is attached. One is C double OH group, carboxylic group, that is at carbon number 1, and carbon number 5 oxygen group, CO group is there, CO. Two group is attached. One is carboxylic group and other is ketonic group, one group, ONE. Then now what will you this, how will you do this naming? Who will get priority out of 2? Then what I have discussed sequence, according to that C double OH will get a priority, and also that is the first carbon. Okay. Then its a name will be 5-oxo, because with carbon number 5 oxo group is attached. 5-oxo hex, because 6 carbon is there total, then it will be hexane. But this is the C double OH group is there, that is the top of priority. Then finally primary group is acid group, oic acid, hence name will be 5-oxo hexanoic acid, because a C double OH group is there. Oic suffix is oic, already I have told you. Then 5-oxo hexanoic acid. Okay. Now here actually in this compound functional group is C double OH, and that C double OH group, that C, that is the got first main primary functional group is that. Okay. Now next example is there, that is the CH triple bond, and again carbon is there, again CH, again CH double bond is there, again CH, again double bond is there, means total 6 carbon is there. And in this 6 carbon 2 double bond is there and 1 triple bond is there. Out of 6 carbon means hex what will come, but here is the 2 groups are attached, double bond and triple bond both are there. Then what will you tell? E you will tell, or YN you will tell primary? That is the question. Then sequence you are knowing, sequence, that first in will come and then last is a triple bond. In sequence I have already told you. Double bond is coming first, and after that it is coming triple bond. Okay, this I have told you in sequence. Then here carbon number 1, carbon actually, because double bond is with first carbon, then obviously that will be the primary also, which is with the first means closest to the got a list number, that is the generally primary will be there, not generally always primary. Then now here 2 double bond is there at carbon number 1 and carbon number 3 got double bond, and carbon number 5 got triple bond. Then name will be rule already we have told you. Here you will tell hexa, AN you have removed, hexane, HEXANE, NE you have removed. Then hexa, it came hexa dash 1 comma 3 di in, di because 2 double bond is there at carbon number 1 and at carbon number 3. Then hexa dash 1 comma 3 dash di in, again a dash 5 dash YNE, because at carbon number 5 triple bond is there. That's why after the die-in, you will write -5-YNE. Now, again I am telling you some more problems which is asked in examination. Now, here they have given the IUPAC name. Now, here IUPAC name is given, and you have to write this thing, sir, a structure. A structure you have to write, IUPAC name is given. Then here I am telling you a question is that chlorohexane, very easy, 2-chlorohexane. Question is given 2-chlorohexane. Name they have given, and you have to write the structure. Then very easy, 2-chlorohexane. Then you write the benzene structure, and you write start numbering. Hexane is there, na? Hexane 1, 2, 3, 4, 5, 6, all 6 carbon you write, and near the carbon 2 give a double bond. One that is question is 2-chlorohexane. Then first you write the this thing hexane, you write a structure, and between first and 1 and 2 you write the double bond. Then it became hexene. From the hexane it became hexene because double bond is there. Then anywhere you can write, wherever you started 1 there, after that you write 2, then 3, 4, 5, 6. Then between 1 and 2 you make a double bond, and that this thing it is not cyclone. The question is only a simple question is there, that you write 2-chlorohexane. Then very easy, hexane you write hexane, and carbon number 2 write Cl. Very simple things. CH2 CH means first carbon, second carbon Cl you attached. It is not cyclic. I was thinking cyclic. It is given only 2-chlorohexane. Cyclo is not there. Ordinary state is there. Then simply 6 carbon you write, hexane you write, and carbon number 2 Cl you put. Then today I am just stopping only here. Again next class again I will continue. Okay, thank you.